constant V, there is a constant V such that whatever be the equilibrium point, that equilibrium point, this one says the following. First one says, if player 2 chooses Y star, he doesn't have to even worry about what player 1 does. Whatever player 1 does, all he can get is only so much. Only so much. And he makes sure, player 2 makes sure it is no more than B. Okay? So, this Y star guarantees the last player 1, player 2 is at most B. Because what? Because K1 is the amount which player 1 collects from player 2. So, what he collects from player 2 cannot be more than B. That is the first statement. The second statement says, let player 2 do whatever he wants. Player 1 can collect in expectation at least B, the same B. So this unique number B is called the value of the game. B is called the value of the game. B is called the value of the game. We call them as, in the case of zero-sum case, we call X star optimal for 1. Y star optimal for 2. Optimal for 2. But the number B is unique, whatever be the strategies. Okay? So there may be several Nash equilibrium points. In the case of non-zero sum, the expectations could be quite different. In the zero sum case, that V is unique. Do you follow me? That V is unique. So now, yes.
Sir,
yeah.
Can you tell us what that mixed X, mixed Y, and is
Can
does
you
it
walk at this for you? Oh, you are watching that. Okay.
Yes, sir.
Yeah. Okay.
Sir, does it mean that it is X, Y, that for all X, or
for all
a particular combination of X and Y, sir?
No. This is for all X.
Sir, this side it is mixed, sir, for.
This is for all Y.
No, sir. Soon after that Nash equilibrium.
Yes. In the Nash equilibrium also, this is for when the other person fixes to Y star, X star guarantees the best for him against any other X.
Sir, for mixed of X, is it, sir?
For all mixed X.
Sir, can you tell me what it is? What is the meaning of that mixed?
Okay,
We
so
haven't defined pure strategy versus
mixed strategy. I'm going to tell you.
Yes,
I'm
yes,
going to tell you. X is the probability of selecting the rows and columns, etc. Okay. I will show you the first a simple example. In the non-zero sum case, I wrote down 4, 1, 0, 0, 0, 0, 1, 4. Do you agree?
Yes.
This is the so-called, this is a movie game, ball game. This is wife, this is husband, movie, ball game. The first coordinate corresponds to what the wife gets. The second coordinate corresponds to what the husband gets. Agree? Now, suppose I write down these two numbers, 3, 4, 1/4, 3/4, 1/4. Now count. Just a minute. Wait for a second, okay? Your way is here. Now, how are they playing the game? I have explicitly constructed a mechanism. That means each one separately writes, they have 5 cards. Yeah? They have 5 cards. Number 1, 2, 3, 4, 5. So, the wife picks up a random card. If it is 1 or 2 or 3 or 4, then she goes and buys the movie ticket. You follow me? If it is 5, she goes and buys the ball game ticket. The same thing the other person also does. If it is 1 or 2 or 3 or 4, the wife, this is not the husband. If it is 1 or 2 or 3 or 4, he buys the ball game ticket. If it is 5, he buys the movie ticket. You follow me? Okay. Therefore, the chance that he buys a movie ticket is 1/5. The chance he buys a ball game ticket is 4/5. Same way with this one. In this case, she also buys movie ticket with 1/5 chance, 4/5 chance, ball game. The other, okay. Now, what is K1 of, this is your X star, this is your Y star. So K1 of X star, Y star equals 4 times, see, she's going to receive 4 provided this, they both buy the movie ticket. Okay? So, for which the chance is 1/25 plus 0 times, it doesn't matter what it is, plus 0 times whatever it is, plus this one is 4/5 times 4/5 is 16/25. Yes. So 1/5. Okay. No. So how much this comes to?
The last item should be 1, right?
Huh?
1 times 16 by 3.
1 times. It is not, because it's all income only for the first player. So 4 times 1/5 times 1/5 plus 0 times whatever it is, plus 0 times whatever it is, plus 1 times. Okay. So this is 20 over 25, which is 450. Take it? Take any x. Let us see what this one gives. Okay. So instead of 1/5, 4/5, I am going to put any general x, 1 minus x. Because this is chosen with probability x, this is chosen with probability 1 minus x. Okay? So that is going to be 4 times x times 1/5, 4 times x times 1/5, plus 0 times, I don't care what it is, plus 0 times, I don't care what it is, plus 1 times, this one is 1 minus x, times 4. But this is the same as again as 4/5. Okay. So it says when this person uses 1/5, 4/5, independent of what this person does, still the payment which the expectation is the same number 4/5. Similarly, you can check. So K1 of x y star is less than or equal to K1 of x star y star. Okay. And this x1, this is called the mixed strategy, equilibrium mixed strategy. Understand? That 1/5, 4/5, 1/5, 4/5 is the equilibrium mixed strategy. Similarly, for K2 of x star y, you can check is also less than or equal to K2 of x star y star, which when you do the same calculation, it is 1/5 times 1/5 times 1/5 times 1 plus the other things contribute nothing. The other one is 4/5 times 4/5 times 4. What is happening? 4/5 times 16 over 25, 64 over 25. What is happening here? 1/5 times 1/5 times. Okay. This let me check the other side. Okay. Equals not what is x equals. X equals to 4 minus x equals to 2. So I subtract 4 minus consider. In action, this has to be you can't do one thing. X equals V2, 4 times plus also V2. So 4 minus 4x equals V2. So 4 minus 5x equals 0. X is equal to 4 over 5. I'm not getting 1/5. This has to be 4 1/5. Okay. Let me start all over again, okay? So, the wife chooses with the 4/5 chance movie, 1/5 chance ball game. The husband chooses 1/5 chance movie, 4/5 chance ball game. Okay? Now, let us do the calculation again. So, it is 4/5 times 1/5 times 4. Let me calculate this again. 4/5 times 1/5 times 4. 4/5 times 1/5 times 4 plus the other things 2 zeros plus 1/5 times 4/5 times 1. Which is 4/5. Agree? Which is 4/5. Scale x y star will also be 4 times general x. You are not substituting 4/5. 4 times x times 1/5, etc., which is also 4/5. Okay? The same way K2 can also be seen. So the actual strategy is, the Nash equilibrium strategy is different. It is, for movie he chooses, wife chooses 4/5, for ball game she chooses 1/5. For the other guy, husband chooses ball game 4/5, movie 1/5. Okay. That's the idea. Okay. But this one is a non-zero sum game. It's a non-zero sum. Now I am going to start with an example of a zero sum game. Okay. A simple example. This is what is called two-finger quadrant. Three, 2, 3, 2, 3. Okay. This is wife. This is husband. I'm now going to write down what each one gets. Okay. They both close their eyes. They both close their eyes and then show either 2 fingers or 3 fingers. They cannot see what the opponent has shown. Only by closing your eyes you can read. You know what you want to do, but you don't want to, the other opponent doesn't want you to know what he or she is choosing. So if both of them show 2 fingers, see the total is what wife gets. So wife gets 4 and that money has to come from husband. So the husband gets -4. Okay. Zero sum means this is the mean. So if she chose 2 and he chose 3, the total is odd. Now husband gets that number, wife loses that number. So wife gets -5, husband gets +5. Are you with me? Now the same way, 3, 2, wife gets, this is, the first one is for wife, the second one is for husband. So this one will be 5, 5. This one will be, wife gets 6, husband gets -6. Are you with me? So that is the game. So the zero sum case, because you know what is the other number, so you keep only one matrix. So you keep always the matrix for the first player, the row player. Okay? Keep only the matrix for row player. Only the matrix for row player. Matrix for cooperative. So all you now do is you write down this 4 -5 -5 6. This entire thing is only payoff for the wife. Okay? So wife, if she chooses 2 fingers and he also chooses 2, then she gets 4. If he chooses 3, then she loses 5. If she chooses 3 fingers and the other fellow shows 2 fingers, she loses 5. If both of them show 3, then she gets 6. Here is a simple question. If they play this game many times, who is better off? Is it the husband or the wife? That is the question. Okay? Now, I am now going to use Nash's equilibrium condition, and what we are saying is find x star y star. X star is a mixed strategy, okay, such that this is your matrix K1. K1 x star y star is greater than sorry. K1 x y star is less than or equal to b. K1 x star y greater than or equal to b for all x and for all y. Agree? So what does it translate to? I write down the translation. Suppose, let us put, this is equivalent to the following 2 statements, summation, summation. So write it as x is not, x is the vector here, but here x is probability. Choosing x and 1 minus x, choosing y and 1 minus y. Special thing is y star 1 minus y star, x star 1 minus x star. So summation, summation. In general, we can write, but here we can write down 4x into y star minus 5x into 1 minus y star minus 5, 1 minus x into y star plus 6, 1 minus x into 1 minus y star must be less than or equal to b. See, I am writing x, this fellow is applying, y is applying general x1 minus x, where husband is sticking to y star 1 minus y star. Then this says this number must be less than or equal to b for every x. Agree? This must be true for every x. So I can put x equals 1 and also I can put x equals 0, particular. So if you put x equals 1, what do I get? 4y star minus 5 times 1 minus y star. When I put x equals 1, this dies, this also dies. So this must be less than or equal to b. I can put x equals 0, these two die, this gives you minus 5y star plus 6 times 1 minus y star must be less than or equal to b. Are you with me? Now I go to this one. I write it down. I have written two inequalities. Now I am going to write down this one. 4 x star times y minus 5 times x star times 1 minus y minus 5 1 minus x star times y plus 6 1 minus x star times 1 minus y. That is this expression. This expression is this. Do you follow? This expression a1 x star y is adopting x star 1 minus x star, but the husband is adopting a general y. Then you can write down the same expectation. That must be less than, this must be greater than or equal to b for all choice of husband. Now husband can put y equals 1, then this gives you 4 x star. When I put y equals 1, this dies. This one is minus 5 times 1 minus x star. Okay? Minus 5 times 1 minus x star. And then this one, when I put y is 1, this dies. Y is 1, this dies. So this one must be greater than or equal to b. I put also y equals 0. Another place. Okay? This dies. So leaving minus 5 x star, because when y is 0, let us put y, yeah, y is 0. This is 5x, minus 5x star. When I put y equals 0, this one is plus 6 times 1 minus x star is greater than b. Okay? This many inequalities are there. And then our problem is I want to find an x star y star. Find x star y star such that 0 less than or equal to x star less than or equal to 1. 0 less than or equal to y star less than or equal to 1. Such that these are satisfied for a unique constant. For a unique constant, that's what the theorem says. So let us do simple calculation now. I am going to multiply this by 5 and multiply this by 4 and add. Okay? I can multiply this by 5, multiply this by 4 and add. So 20y star minus 25 times 1 minus y star is less than or equal to 5b. When you multiply by a positive quantity, the inequalities are maintained. This one, I can multiply this by 4 minus 20y star plus 24 1 minus y star is less than or equal to 4b. Agree? Now, if two inequalities are there, you can add them, they maintain the inequality. So this dies. So this gives you minus of 1 minus y star is less than or equal to 9b. When you add these two, you left with minus 1 times 1 minus y star is less than or equal to 5b plus 4b, 9b. Okay? 1 minus y star is anyway something non-negative, so this one is negative. Negative or 0, and that one is less than or equal to 9b. Okay? So from this, you can get one condition. B must be greater than or equal to minus of that's all you know. Agree? Now let us do the following. Okay. Now I am going to multiply this by 5 and this by 4 and add. Okay. If I multiply this by 5, I get 20y star minus 25 1 minus y star is less than or equal to 5b. Now I multiply this by I multiply this by 5. I multiply this by 6 and this by 5. I multiply this by 6, 24 y star minus 30 1 minus y star is less than or equal to 6b. If I multiply this by 6. If I multiply this by 5, minus 25 y star plus 30 1 minus y star is less than or equal to 5b. Agree? So when I add these two, I get minus y star is less than or equal to 11b. Minus y star is less than or equal to 11b. Okay. So can I look at this extremely clear two-way to example? And basically it is an inequality. So we know minus y star is less than or equal to 11b. This one says minus 1 minus y star is less than or equal to 9b. If I add these two, what do I get? Minus y star minus 1 minus y star is minus 1. Okay. Minus 1 plus y star minus y star. And then this one is less than or equal to 20b. So this implies b is greater than or equal to minus 1 over 20. That's all it says. It is still not nailing down what is b. It is only saying b is at least minus 1 over 20. Now go to distances. you went through this one, similar calculation, it will show you that B is less than or equal to minus 1 over 20. By using this second one. Because in the same method, from this we get what is V. V should be equal to minus 1 over 20. So, after so much struggle, we are able to determine what is V. So, V equals minus 1 over 20. Now, let us go back and plug in this. These are now. We'll keep only this. Okay. 4y star minus 5 times 1 minus y star is less than or equal to minus 1 over 20. B is minus 1 over 20, we already know. This one is minus 5y star plus 6 times 1 minus y star is less than or equal to minus 1 over 20. Okay? Now, we can solve this one, inequality. So, 4y star plus 5y star, which is 9y star, minus 5 is less than or equal to minus 1 over 20. This one is minus 11y star plus 6 is less than or equal to minus 1 over 20. Okay? Now let us take it to this side. So 9y star is less than or equal to 5 minus 1 over 20. You know, very early. From this one, I get this. So y star must be less than or equal to 11 over 20. Okay? Now let us go on plugging this one. This one. So minus 11y star is less than or equal to, add minus 6 to both sides, is less than or equal to minus 6 minus 1 over 20, which is less than or equal to minus 121 over 20. So when I divide by negative sign, the inequality reverses. So y star must be greater than or equal to 11 over 20. So y star must be 11 over 20. One minus y star is 9 over 20. That is the good strategy for the column player. Okay. Similarly, what was our matrix? Let me eliminate this. So what was our original matrix? It was 4 minus 5 minus 5 6. Yes, is that wrong? That's what it was. And 4 x star minus 5 times 1 minus x star is greater than or equal to minus 11 over 20. So now I am going to manipulate the same thing. So 4 x star plus 5 x star. So x star is greater than or equal to minus 11 over 20 minus 5. You know the rule to be done. What was wrong? 4 x star minus 5 times 1 minus x star is greater than or equal to minus 11 over 20. Was it minus? No, minus 1. V is minus 1 over 20. Good. 4 x star plus, this is 9 x star. 4 x star minus 9 x star is greater than or equal to minus 1 over 20 minus 5.
Plus 5.
Huh?
It is plus 5.
Plus. Yeah. So this one is 99 over 20. So x star must be greater than or equal to 11 over 20. You can show x star is also 11 over 20. Like y star, x star is also 11 over 20. And 1 minus x star is 9 over 20. So this much of calculation by brute force is required to solve a simple 2 by 2 game. Okay. So you start expecting any intelligent solution better than this. Till then you don't have the full evaluation. I want to tell you why I took this roundabout thing. Von proved that any matrix A equals AIA as the payoff matrix for the first player in a zero-sum game has good strategies x star y star and value B. He didn't know how to find B. He didn't know how to find x star and y star, some good strategy. Then he wrote this itself, the existence itself, the paper which he wrote, he was 20. At the age of 20, he proved this Fermat's theorem. And the paper runs to 28 pages of small print proof. His proof was so difficult, incredibly difficult proof he gave. This was in 1928. In 1937, a French mathematician by name Billet, he realized that this can be seen in a very ingenious fashion by the notion of convex sets. That's what I'm going to come to. And then, even though he also knew this, but he didn't know how to solve it. French people are never interested in computational side. Invariably, they are very happy to prove the general theorem and be done with that. Okay? They don't want to see God. They want to see God exists. That's enough for them. Okay. And then George Danzig, who was working on linear programming, he was himself not sure what is linear programming in all its clarity. He came to von Neumann and talked to him. Von Neumann said, an equivalent theorem to what I have proved exists within the linear programming setup called the duality theorem. He orally mentioned the duality theorem. He didn't do anything more than that. He said, I'm telling you, you use the duality theorem, and then you should be able to develop a method to solve for it using the duality theorem. Using the duality theorem. And it took another 2 years to develop the full power of that, and that's what he used to solve for games. Okay, that's what he was. Okay, so what are the 2 things which remain? We can assume, today we will assume that von Neumann's theorem is true and show how we can use linear programming to find the solution. You follow me? Today we will use linear programming as to how to solve for the game. Okay? Let us take without going too much into the details. Point under. This is pay off to the wife. From husband. So it is 270709. What is this game? Wife chooses first row or second row. She will not tell which row she is choosing. Husband chooses first column or second column or third column. He won't tell which column he is choosing. After they have done, suppose his wife chose the first row and husband chose the third column, husband pays nothing. If wife chooses the second row and if the husband chooses the first column, then wife gets $7 or 7 rupees from husband. She is always on the receiving end. Even if she is on the receiving end, that doesn't mean anything. What is the least which he can give to her? So he is a very stingy guy. He doesn't want to part too much money. Wife is spendthrift kind. She wants to maximize whatever she can get out of this fellow. And he is not willing to divulge everything in this game. So the husband says, you choose whatever you want, I choose whichever I want. And then let us take the chance, okay? And then, now the minimax theorem says the following. So let me write down the minimax theorem, not for this matrix, in general. Okay? Given K equals Aij, M by N matrix. So wherever row, wife, column, husband's wife. There exists x1, x2, x1 star, x2 star, xn star, non-negative, sum of all the xi star is equal to 1. That means each row is chosen with certain probability. The first row is chosen with probability x1 star, the last row is chosen with probability xn star, and there exists y1 star, yn star, summation yj star is equal to 1. And a unique constant B such that summation aij xi star I equals 1 to n is greater than or equal to B for all j. For all j. Summation aij yj star is less than or equal to B for all I. Okay? For all I. So what is the intuition? It says, if the wife selects the ith row with probability xi star, and she may not know which column that the husband selects. Suppose the column is j column. She doesn't have to worry about what column he chooses. Her expectation is, if he chooses column j, this is the amount which she can expect. If he chooses column j, this is the amount which he can expect. And that guarantees a number B. For whatever column husband selects. He may select in a particular column, he may gamble and select. You do whatever you want. Still, that is the amount guaranteed. The second one says, no matter what, if the husband selects jth column with this probability, he doesn't have to worry about which row she selects. Whichever row she selects, she cannot get more than B. on the expectation. So her expectation is contained by this number V, by this good strategy of husband. Her expectation is guaranteed to be at least V, okay, against any strategy of the opponent, husband, V. So this V is called the value of the game. These are all good strategies. V is unique, but these need not be. X star and Y star need not be. There can be multiple strategies which are good. You follow it? There are multiple strategies that are good. So now I am going to consider this game. Okay? How do you find the B for this game? Okay? So now I am going to brutally write down. First thing is, since B is unique for this game, let's take a simple example. Suppose the husband selects all the columns with equal chance. Okay? So if she chooses this, the average income will be for her is 2 plus 7 plus 0 divided by 3, which is 3. So if she chooses this, she will get 3. If he is sticking to 1/3. If she chooses this one, it is 9 plus 7, 16 over 3. Either she gets 3 or 16 over 3. So the worst scenario is this one. So if the husband chooses all the columns with equal chance, sure he is not going to lose more than 16 over 3. Do you agree? So if he chooses all the columns, suppose the husband chooses only the first two and never this one. So husband tosses a coin. If it is head, he chooses this. If it is tail, he chooses this. He doesn't choose the last toss. So how much the wife can expect? Either 9 over 2 or 7 over 2. Do you agree? See, the average income for the wife will be either 9 over 2 in case she chooses this, 7 over 2 in case she chooses this one. So certainly it is no more than 9 over 2. So 4.5. Between the two strategies, which is better? The first strategy was for the husband to choose this and ready to risk 16 over 3, which is 5 and 1/3. If it is half 0, ready to risk 9 over 2. Of the two, which is better for the husband? Yes? The second one. Okay. My question is there something better than this? Is there something? I know between these two, this is better. That doesn't mean this is the best. I could try something else. So let's try one more. Okay? Zero. Suppose they try this one. Let's do this. Instead of choosing the first, second, and third, first and second alone, he chooses only second and third. That's good. So now calculate what is the amount which he should be ready to lose if it is 0 half the time it is 7, half the time it is 0 if she chooses the first row. So it will be 7 over 2 or 9 over 2, which is again 4 and a half. So that means this is also, you should be willing to lose up to 4 and a half. So this and this, they are on equal terms in some sense. But that doesn't still mean this is the best. There should be something better. Okay? So I'm going to write down what is better and check what it is. Okay? Try this. Let's try this one. Okay? If the husband selects these two with 9 over 16 and 7 over 16, if she chooses the first row, so she is going to get on the average 63 over 16. Are you with me? If she chooses the second one, that is also going to be 63 over 16. Are you with me? Do you see it is 63 over 16? If you are not sure, tell me. Are you clear with this? No. Okay. So, the first row she is choosing. So, this guy is not choosing the first column. He is only choosing this with 9/16 chance and 7/16 chance. These two. So, 9 out of 16 times he will choose the first, this second column. 7 out of 16 times he will choose the third column. So, if she chooses the first row, so she is going to get 7 with this probability, 0 with this probability. Okay? So, 7 times 9 over 16 plus 0 times 7 over 16 is exactly 63 over 16. Are you with me? The same way with the second one. 0 times 9 over 16 plus 9 times 7 over 16, which is 63 over 16. This is slightly less than 4. The previous one was 4 and a half. This is slightly less than 4. And this guarantee is independent of which row she chooses. Okay? In fact, this is the value of the game. In fact, the value of the game B is 63 over 16. And these things are good strategies. Which one? 0, 9 over 16, 7 over 16. And she chooses okay, 9 over 16, 7 over 16. Now let us look at this. Suppose instead of choosing this, suppose husband always chooses the first column. If husband always chooses the first column, if the wife chooses the row 1 and row 2 with this probability, what is wife's expectation? Her expectation is if she will receive 2 with this probability, 7 with this probability. So this is 7 times 7 is 49 plus 9 times 2 is 18. 49 plus 18 is 57. 67. 67 over 16, which is even better than 63 over 16. So now if she chooses this one, if he chooses always this one, then this is what is going to, she is going to get 63 over 16. If she chooses this one, yes, 63 over 16. So in a sense, what is good for the husband should never choose the first column. He should avoid first column. He should choose second and third with this probability. She should choose both rows. She should suppose let's take the following. Suppose suppose instead of doing this, can she always choose the first row? If she always chooses the first row, still she will get an expectation of 63 over 16. If she chooses second row always, then also she will get. But you have to remember, the moment she does this, suppose she always chooses this. She says, I'm going to choose this. She even tells the husband. Now what will happen to the husband? Husband will know this woman is stupid. Okay? So he would always choose this one. So there is, you need to gamble, you shouldn't keep always the same thing. Okay? And nothing else is, for example, if she chooses this one with probability half and half, that's also no good. Because then what he will do is, he will always choose this middle one. Because then he is only giving a 3.5 expectation. So this is the correct good strategy, which is unique. This is the good strategy, unique. No other strategy exists. Okay? So that is the, so this was the problem which they were facing. Phenomenon was facing everybody. Now, how to convert it into linear programming? That's what I want to do now. By simple tricks like this, we know that B is positive. We know that. Okay? We know B is positive. So, what I want to do is find Y1, Y2, Y3 such that 2Y1 plus 7Y2 plus 0Y3 is less than or equal to B alpha 7Y1 plus 0Y2 plus 9Y3 less than or equal to alpha Y1, Y2, Y3 non-negative summation, Y1 plus Y2 plus Y3 equals 1. Okay? Can I find Y1, Y2, Y3 satisfying all these conditions? For some alpha, suppose you put alpha as 10,000, you can always get it. Okay? If you put alpha equal to 10,000, you can put any Y1, Y2, Y3 such that this condition is satisfied, it won't. This will be automatically satisfied. And I want that alpha to be as small as possible. As small as possible. So my idea is find Y1, Y2, Y3 such that this is true and alpha is the least. Alpha is the least. Before? Okay. The little trick is, you can assume alpha has to be positive. Okay? So I can divide by alpha and write down 2y1 by alpha plus 7 y2 over alpha plus 0 y3 over alpha less than or equal to 1. 7 times y1 over alpha 0 times y2 over alpha plus 9 times y3 over alpha less than or equal to 1. And y1 over alpha, call it as theta 1 greater than or equal to 0, theta 2 greater than or equal to 0, theta 3 greater than or equal to 0. What is theta 1 plus theta 2 plus theta 3? How much is that? We are assuming y1 plus y2 plus y3 is 1 because that's what we. So this one is y1 plus y2, theta 1 plus theta 2 plus theta 3 is y1 over alpha plus y2 over alpha plus y3 over alpha, which is equal to 1 over alpha. Okay? So my problem is reduced to, I have somehow completely eliminated one variable b and replaced it with simply number 1 on the right side. And then this one, 1 over alpha, if alpha is to be least, 1 over alpha should be as long as possible. But 1 over alpha is also theta 1 plus theta 2 plus theta 3. So I am going to write down all these inequalities as the following linear programming. Maximize theta 1 plus theta 2 plus theta 3 subject to 2 eta 1 plus 7 eta 2 plus 0 eta 3 is less than or equal to 1. 7 eta 1 plus 0 eta 2 plus 9 eta 3 less than or equal to 1. Eta 1, eta 2, so I not very 1. Not high. Eta 3, non-negative. That's all there is. Do you follow? So I have reduced my original problem to this linear programming problem. So how many of you are familiar with linear programming, simplex method? Do you know simplex method? No, you don't know. So I'm telling you. You know. Okay. So this is the problem. See, some students know, some students do not know. So I need to assume the worst scenario that nobody knows. And then start building from that so that the class can follow it. Okay? Now I am going to develop as from scratch. Okay? What I do is the following. I will give you these notes also, okay, but in the meantime, see whatever is this gap, see, 2 eta 1 plus 7 eta 2 plus 0 eta 3 is less than or equal to 1. Whatever is this gap, I can replace the gap by a new variable, okay. So I am going to write this as 2 eta 1 plus 7 eta 2 plus 0 eta 3 plus eta 4 equals 1. The gap is eta 4. The second one is 7 eta 1 plus 0 eta 2 plus 9 eta 3 plus the gap is some other variable eta phi equals 1. Are you ready? Okay. Now, I call the C as 1 eta 1 plus 1 eta 2 plus 1 eta 3 plus 0 eta 4 plus 0 eta 5. That is my subjective function. Do you follow me? The subjective function eta 1 plus eta 2 plus eta 3 plus 0 eta 4 plus 0 eta 5. So my aim is to maximize Z, such that this is true and all etas are non-negative. All etas are non-negative. Non-negative. Okay? Can you think of one solution, clear solution? You can think of any solution which satisfies this. Can you think of a solution? Huh?
Eta 4 is 1, eta 5 is 1.
Eta 4 is 1, eta 5 is 1. So here is the solution. Here, feasible solution. It's called a feasible solution. Eta 4 equals 1, eta 5 equals 1, eta 1 equals 0, eta 2 equals 0, eta 3 equals 0, and therefore 3 is also 0. Agree? Now, what you do is you write this whole expression as follows. Eta 4 equals 1 minus 2 eta 1 minus 7 eta 2 minus 0 eta 3 eta 5 equals 1 minus 7 eta 1 minus 0 eta 2 minus 9 eta 3 and Z equals eta 1 plus eta 2 plus eta 3. You put underline. Do you follow me? This is what is called a dictionary. The one variable on the left side, they are called basic variables. The variables on the right side are called non-basic variables. Non-basic variables always take the value 0. In general, the basic variables take only positive values. So if I put either 1 0, either 2 0, either 3 0, I get either 4 as 1, which is positive, therefore this is a basic variable. Similarly, this is a basic variable. So now given this, what is the best which you can do to improve? Can I get an improvement? Right now they are all 0. I can probably try to say, because I want to minimize my work, so I know exactly the answer is there, therefore I want to choose the right one. I can increase eta 3. If I increase eta 3, what will happen? The Z value will be positive. Then I only increase only one of these variables. Other variables are kept at 0 because the all are non-basic. So I want to increase, so that it becomes basic. So I increase in such a way that this becomes basic. Some fellow on this side becomes non-basic. This is the idea. The idea is to increase this in as much as you can, such that one of these basic variables becomes non-basic and this becomes basic. For example, right now eta 3 can go up to what? Can I make eta 3 as 1? See, this one is 0, this one is 0. I have fixed it. This is the only one I can increase. If I increase this as eta 3 as say 1, this will increase. But unfortunately, this whole expression will become negative. Because then it will be 1 minus 9, which will be negative. But I want to increase such that these still retain they are non-negative. So I can go only up to how much? Huh? 1 over 9. If I increase beyond 1 over 9, this whole expression will become negative. So I want to increase up to eta 3 is equal to 1 over 9, such that this block becomes 0. So that means this becomes non-basic, this becomes basic. You follow? This becomes basic, this becomes non-basic. So that is the swapping of the two things. So I swap it now. So I can write down the same equation in the other fashion. So eta 4 equals 1 minus 2 eta 1 minus 7 eta 2 minus 0 eta 3. This one is 9 eta 3 equals, take this one to this side and this one to this side. 1 minus 7 eta 1 minus 0 eta 2 minus eta 5. Clearly? I take this one to this side, this one to this side. So 9 eta 3 is 1 minus 7 eta 1 minus 0 eta 2 minus eta 5. So I want the variables to be fixed. Eta 4, eta 3, from this you get eta 3 is 1 over 9 minus 7 over 9 eta 1 minus 0 eta 2 minus 1 over 9 eta 5. Really? Now this one is eta 4. I express every basic variable in terms of only non-basic variables. So eta 4 is 1 minus 2 eta 1 minus 7 eta 2. It's nothing there because there's 0. Okay? So I have gotten expressed everything in terms of these are the new basic variables, these are the new non-basic variables. Now what is Z? I have to write down this also, that is eta 1 plus eta 2. Instead of eta 3, I should write down this whole nonsense. Are you doing? Instead of Z, I should replace the eta 3 by other non-basic variables. So this I have done. So let us see what happens. So let me write down eta 3. I have to copy these two. See, there is 1 eta 1, there is minus 7 over 9 eta 1, so it is 1 over 9, this is answered. This one is 2 over 9 eta 1. 2 over 9 eta 1. There is 1 eta 2, there is 0 eta 2 plus eta 2. This one is minus 1 over 9 eta 5. Okay. So what is the new solution? Can you find it? Always the easiest way to find the new solution is, whatever is the variables to the right, you make all of them 0. So when I put eta 1 0, eta 2 0, eta 5 0, I get eta 3 as 1 over 9. So eta 1 equals eta 2 equals eta 5 equals 0, eta 3 is 1 over 9. Now what is the value of Z? 1 over 9. Previously the value of Z was 0, the first state. Now the value of Z has improved to 1 over 9. Agree? Now our question is, can I improve further? For example, if I increase eta 1, this will improve. Or if I increase eta 2 also, it will improve. I am going to try eta 2. Okay? So how far can eta 2 go? See, anyway eta 1 is 0. I can only increase eta 2. Eta 2 can go such that you still maintain the non-negativity. So how far it can go? 1 over 7. Okay? So that means this variable becomes non-basic. This variable becomes which one? This one. Yes? Basic. So I swap this equation like this. So 7 eta 2 equals 1 minus 2 eta 1 minus eta 4. 7 eta 2 equals 1 minus 2 eta 1 minus eta 4. Which is the equivalent to saying, okay, now let us fix this up. Eta 3 equals 1 over 9 minus 9 over 7 eta 1. Luckily, eta 2 has no position here, minus 1 over 9 eta 5. Okay? But Z will have the effect. Z is 1 over 9 plus 2 over 9 eta 1 plus, instead of eta 2, I should write down this expression. Because eta 2 is this. Okay? So that is eta 2 is, where is that? 1 over 7 minus 2 over 7 eta 1 minus 1 over 7 eta 4. That is this expression minus 1 over 9 eta 5. Okay? So let us copy that. So the last one alone I am trying to keep. Z equals (16 over 63). If I add these two constants, it becomes 16 over 63 plus 2 over 9 eta 1 minus 2 over 7 eta 1, which is plus 2 over 9 minus 2 over 7 eta 1. Don't do any calculation. Minus 1 over 7 eta 4 minus 1 over 9 eta 5. Okay? And you can copy the eta to eta 3, whatever is this. Okay? Now, the variable to the right, what is the solution? Basic solution. Put all the variable to the right as 0. So this is 0, this is 0, this is 0. So what we are now getting is 16 over 63. G is equal to 16 over 63. And then eta 2 equals, when I put this is 0, this is 0, I get eta 2 is equal to 1 over 7. Eta 3 equals 1 over 9. Eta 1 equals 0 because it is on the right side. Now look at this. Other than this coefficient is negative. 2 over 9 minus 2 over 7 is negative. Minus 1 over 7, negative. Minus 1 over 9, negative. Okay? So, can I improve beyond this one? Only way improving is to increase eta 1 or eta 4 or eta 5, which will only decrease the value because these are negative coefficients. It will only decrease the value. Therefore, we have already reached the optimal value. You can't improve any further. Before, this is the spirit. So now we go back to the game. Go back to the game. Y2.
Is it right time to interrupt you?
Huh?
Is it right time to interrupt you?
Yeah, this is the last line.
Suppose there are only two constraints.
Yes.
And when we use this method,
Yes.
there may be many variables involved.
Yes.
We get only two variables non-zero
Yeah.
in the optimal solution.
Always it is only two variables. But which two variables we don't know.
Yeah.
That is the whole
Why
work.
only two variables will get non-zero value? Why
Yes.
not more than two?
Correct. In this case.
How do we convince? Yeah, in the method,
Yes.
we get two variables non-zero.
Yes. So
Get to
okay.
attain
Now that the whole idea. Why is so? Why that means that is part of the general theory. The general theory is if you have a feasible solution, any feasible solution in this problem, I can find what is called an extreme feasible solution. The extreme feasible solution will have only, in this case, only two variables possible, maximum. Now, if you have an optimal solution, you have an extreme optimal solution. Okay. So, and that has something to do with basic solutions. That has something to do with the notion of basic solutions. I only introduced the word basic, but next time I am going to introduce formally what is the basic solution. So that means we are not searching every solution because a set of solutions is a very uncountable number of elements are there. But we are concentrating only on very boundary extreme points. I have explained the geometry of that one. And that is the reason why the whole search is restricted to finitely many solutions. You don't go beyond that. And still you can get the answer. That's the idea. So let me finish this last portion. If y2 is eta 2 over v, y3 is eta 3 over v, y1 is eta 1 over v, and 1 over v is z, which is 16 over 63. Therefore, v must be 63 over 16. You follow me? V must be 63 over 16. And when I multiply each one by 63 over 16, y1 is, eta 1 is 0. So y1 should be equal to 0 over v. y2 must be equal to, eta 2 is how much? Eta 2 is 1 over 1. 1 over 7 over 63 over 16, which is equal to 9 over 16. 16, YD is 716. Okay? Incidentally, I only found the solution for the column player. But these expressions also contain actually the answer also for the row player. The same linear programming problem. When the final table comes, the final table has also the answer for the row player. Okay? So, it is 16 over 16. This I have explained next time. Now I cannot. Okay? I have to explain next time. So, but this method, the way I have done today, you should see the book by Waka, Linear Programming by Waka. And this book, in the first 15 pages, it winds up the simplest method. Okay, it winds up the simplest method. But what has happened to because of the computer technology, a lot of people may not have to know anything about how the method works. Okay? So all you do is you write down the matrix, you write down the vector, and it spits the answer. And you think you have got the answer. Somebody spit the answer for you. Okay? The software technology is so advanced that you can solve up to 16 decimals or 32 decimal kind of nonsense. But the basic principles we have to understand how it works as mathematicians. Okay? That is the reason why you go through the longhand process of solving them. Okay? That is the main reason. And because that was a struggle for nearly from 1928 to 1965 to do this little thing. What we now did today is only such a thing. It took so many 40, 50 years. So we don't appreciate how much difficulty they have gone through. Including people like Von Neumann worked in 10 areas of mathematics. For example, he did profound work in functional analysis. His book, his lecture notes on called Functional Operators, is an incredibly beautiful book. I was fortunate at the Indian Statistical Institute as a graduate student. I joined in 1962. There were 4 superb mathematicians. One was V.S. Varadarajan, another one was S.R.S. Varadhan. The third one was K.R. Parthasarathy. Fourth one was R. Raghavan. But whatever I learned in analysis, functional analysis, is all from Varadarajan. Varadarajan joined ISI as a graduate student in 1956. In 1958, he submitted his PhD thesis. And in 60, he was invited to the Quran Institute of Mathematical Sciences, to Princeton University, Seattle, Washington. After finishing, he came back to ISI. He was itching for students, the way I am itching for good students. Not that they have to give me anything. I want to share my knowledge, whatever I have, with good students, so that they gain something. See, even the Vedic sentences say that. Sahana bhavatu, sahanam gunattu, sahavityam karavavahai, tejasvi navati tamastu ma vidyushavahai, om shanti. So the teacher is actually waiting. I want to give my knowledge to you. And I also want to learn from you. Not that I am an expert in everything. I also want to learn from you. That respect is there. So that knowledge, that's how the Gurukulam was only there. This teacher's house, the students came. At that very young age, they were set. Even the king, royal family, said, you know about Mahabharata and other things. How Drona. And Drona, all these people were trained. So, it's the same thing. So, they learned archery and other things and being kings. Under Vasika, they learned other philosophy and things like that. And that knowledge is important. Upanishad is learning something near your teacher. Because when you have a doubt, immediately you ask that doubt, and then the teacher clarifies. That is the very important thing. And they share the food and they stay with them, and then you have all the time and leisure, and there are no recreations. Because they immediately stayed in forest. So in our case, in my case, the equivalent of forest was my village. There was no TV, nothing. The people had to be only working with each other. So that's the idea of Gurukulam. So I believe even all of you, even if I take a little longer sometimes, I may not get every day with the same amount of time. But be patient because you are going to gain something. Gain something in analysis, something on spectral theory, something on combinatorics, everything you will learn. And how to solve. In many of them, how to solve is the key. I don't want to deviate from how to solve, so that you know, given a problem, you know how to solve it. Yeah. If you have any question, please ask me. So we have finished zero-sum 2% games. We have defined what is a non-zero-sum 2% game Nash program. We also know how to solve the zero-sum 2% game via the simplest method. What we did now is solve the simplest method, but the only difference is I am actually writing all the variables. It's a waste of time. There is a condensed way of writing the whole thing, and that is what is called the simplex table. And the way I substituted brutally, that you do by pivoting. Okay? By pivoting, you do all of them. So then you do it mechanically. You do it mechanically. Once you do it mechanically, if you know enough programming, you can as well program it. Okay? But that doesn't mean programming is easy, because you can make a number of mistakes. I will tell you with Robert and myself. Robert was my student. Okay? So we both were exposed to what is called the Fortran programming. And then I asked, there was one graduate student who was teaching it. I said, this is all Fortran, what is the big deal? And then Robert said, Professor, you have learned the alphabets. Now you can write down Shakespeare out of it. That's what he said. Then I said, no, I am sure I can do that. Then he asked me to write a small program to find how numbers divisible by 9 from 1 to 1000. So I wrote a program. It said that 1 is not divisible by 9, 8 is not divisible by 9, 9 is divisible by 9. After that, it started saying 10 is divisible by 9, everything was divisible by 9. So where the mistake was, I don't know where the mistake was. It took a while. So, since we value people who write programs also, hard work programs. Okay. What is the time now?
3:45.
Huh?
3:45.
3:45. Okay. So I think that is enough for today, isn't it? Or I can continue. I have no problem. It's too much. Yeah. Tomorrow we start at the same time, 10 o'clock.
You are giving some problem. You are expecting them to solve some problem.
Huh?
You are expecting them to solve some problem and come tomorrow.
No, the homework, whatever is the tutorial problems. So if you can solve the tutorial problems, whatever you can solve, whatever you cannot solve, you come. Whatever you cannot solve, you put a star and say, I am not able to solve it. Whatever you can solve, please do that. So it's in mathematics, the only way you learn is by solving problems. Nothing else.
Tomorrow, sometime they can.
Huh?
Tomorrow, sometime they discuss the same thing.
Yeah, we can. No. I have to move on.
Yeah.
Between,
not during your lecture time.
Yeah.
Beyond the lecture.
they have, in between them, they can discuss. No problem, they can mutually help each other to solve the problem also. Finally, it's learning, nothing more. Okay. Finally, it's just learning. Because the next step is to, like the way I did for the linear programming, use linear programming to solve the zeros and 2% games. I can give a couple of some other example to attack. Okay. Then when I come to the bimatrix game, that is a very difficult part of the whole thing. And that requires certain preliminaries, like when you ask the basic feasible solution, etc. And from there only it moves at non-degeneracy hypothesis and things like that. And that may not end by tomorrow. It may go also day after tomorrow. It will take, actually, if I want to formally prove everything, I did it for my graduate students. Some 4 graduate students who are taking the course, and then there were some 3 from engineering and others also came. But I took 2-hour lectures, 5 2-hour lectures to finish formally the proof of why MK house and algorithm works. I wouldn't have the time for that here, but I would know how to manipulate and which one to skip. You see, also in knowledge can come, as I used to say, in 4 different ways. Pratyaksha, what you see is one way of acquiring. Anuman, inference, through which you pick up knowledge. Upaman, by analogy also you can pick up. Shabdam, which means scripture. Somebody says, this is true. As a teacher, I am saying it is true. You have to have a belief in me. That's also a knowledge. Okay. Science will not accept non-belief. See, hydrogen plus oxygen is water is said. We are not doing, everybody is not doing experiment. Somebody has done experiment, 100,000 people have done experiments. So you are willing to take it. So the same way, portions of the algorithm where the theory is somewhat difficult to prove, we will swallow. It doesn't matter, really. For the first round of learning, that is good. But I want to also, so that you are actually, like the way you solve a simplex algorithm, you can do it mechanically. But the mechanical thing should come a little later. First, I should know the formal basic ideas of the finding the Nash equilibrium for bimatrix games.
Dear participants, today we wind up our sessions. Tomorrow session start at 9 o'clock. Okay, and
10 o'clock, 10 o'clock. Oh, you want it at 9? Yeah, I can start at 9.
Sorry, 10 o'clock.
Routine.
10 is better.
Tomorrow session starts 10 o'clock.
Any instruction for
Assignment.
How will they submit the homework?
Scan and mail to us.
Huh?
They can write scan and
Mail, yeah. So it will come to me in my email or what?
No,
If
you
it comes to you, then you can give it to me. Give me a copy, hard copy.
Okay.
Otherwise, you send it to me by email, I can go through that.
That's better.
That is better. Why waste the paper? I can go through that paper. They think, look at it.
Yeah, you can keep.
So try to complete the assignment given today. If any unknown things are there, you can ask sir tomorrow.
Yeah, they can show up and discuss.
Yeah. Tomorrow you can discuss if anything you want.
Whatever you
Not
want.
during the routine lecture, in between, during break.
Yeah, that I told. And you can also ask questions in between the lecture. Okay, thank you.